So this video here is going to go through sample paper A, question 2, parts A, B, C and D, and then I'll release a second video showing how to do part E, which is going to be the elevation and plan of the camera shown here. So it tells us shown below is a 3D model of a camera. Also shown is a drawing of the LCD panel on the top surface of the camera, which displays information such as the battery level, photo histogram and other camera related settings. Part A, the outline drawing of the battery level display is shown below. Shade the display to show the battery level displaying 40%. So if we count it out here first, you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be 10 bars, and they want us to do it as 40%. If we take 40 out of 100, it's going to give us 4. So we're going to shade in our first 4 bars there. So we can just use our pencil as normal to shade inside and just try to keep inside the lines as best as we can. Part B then, it tells us an incomplete drawing of the photo histogram display is shown below. Complete the drawing by constructing an axial symmetry in the line L1. So what we're doing is a mirror image of what we see on the left here onto the right. So to start off, I'm going to take my height here of my first part of the histogram, and I'm going to take the width of it there. So I took that width and I'm applying it to the other side. I can then draw in that bar as a mirror image now. And I'm going to do the exact same thing for the second, third and fourth one. So you can see I'm taking a light line across from my height. So I'm going 90 degrees to my axis there. Take my width there, mark it off, take that down, and the exact same thing now for third and fourth. Take my height there, take my width there, and then the bottom one there. Take my width there, mark it off, and now I have part B complete, showing the mirror image of the histogram from the left onto the right hand side. Part C then tells us the camera company wish to place a triangular button ABC on the back of the camera. The XY line below is the perimeter length of triangle ABC, and it has sides in the ratio of 3:4:5. Draw the triangular button. So the first thing here is looking at the perimeter. If we were to draw a triangle there like that, the perimeter would be, if I added up say A, B, C there, if I added up the distance A to B, B to C, C to A, that would add up the length to be, say, my XY line there. So it's like getting a piece of string, joining it from A to B, stretching it out to B to C, and then finally around C to A, taking it and stretching it completely out, and that would be your length then, it would be your perimeter. So the second part then, it looks at a ratio of 3:4:5. So the first thing we need to do is take those 3 numbers and add them up to give us 12. And what I'm going to do now is divide this line into 12 equal parts so that I can get one side as 3 parts, and our side is 4 parts, and the last part as 5 parts then. So I take a line at a random angle, and I'm going to step out. I use my compass to step it out, so I don't want to try and go into my sketch there. I'll step out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So that's just taking an equal distance of my compass all the way out, or if you want to, you could get your set square and go say 10, 20, 30, 40, 50. Now to make sure I'm right, I'm going to label them like this here to make sure that I've stepped out 12 equal parts. After that, we have to use sliding set squares. And join the end point 12 to Y there, and then using sliding set squares take my points up. So these are all running parallel to each other, dividing that line XY now into 12 equal parts. Now you can see my XY line is divided into 12 equal parts, and the key thing I want to take here is, I'll just use colours to show you. So for example, I could have these 3 colours here, and I'm going to use each one to represent each part of my ratio. So for example, I was saying there, lads, I just got an interruption there. We were looking at the ratio there, so it says 3 is to 4 is to 5. So I'm going to use the colour to represent the length of each side. So if we take, for example, the 3 there, we go 1, 2, 3. That pink length there represents one side of our triangle. We could say, for example, it's this side here, and I'll explain why after. The next part then is our ratio of 4. I could use orange for that. We go 1, 2, 3, 4. So you can see from there to there is our 4, and we can say that that's the base of our triangle there. And the last part then, our 5, which is going to be this side here, and you can see we have 1, 2, 3, 4, 5 left. So that's why we divided it into 5 or 12 equal parts first, because when we add up our ratio and then divide it out, then we have 3 is to 4 is to 5. So the reason why I went with that colour the way it is there, how I have the pink on the left, the blue on the right and the orange in the middle, I'm going to use this as my base here. And what I'm going to do is, I'm going to take the length of my ratio 5 there. There's my bottom corner there of the triangle. I'm going to rotate that around. You can see there, that distance from there to there is the exact same all the way around from that point, from that corner there. I'm going to do the exact same from this corner now with my pink length, my ratio 3. I rotate it around. You can see they cross over each other. Where they cross over each other, that gives me my apex, my top of my triangle. So you can see there, that length there is the same as that length. That length there is the same as that length. I already have my orange one. So now what I've shown is a triangle of a ratio of 3 is to 4 is to 5 then. Now I could decide if I wanted to have the base of the triangle as pink. All I do is take, say, my orange distance there, rotate it around, take my blue distance there and rotate it from this end around to meet it. I decided to use the middle one as the base so I could rotate each of them around, make it nice and neat there in the centre of the drawing. Last part here for this video then, part D. A navigation button is also to be added to the back of the camera. This will be based on a regular octagon with a base length of the line PQ below. Draw the navigation button. So you can see that's the base of it there. We know from our polygons that an octagon has 8 sides, and we take 360 degrees and divide it by 8, we get 45 degrees for the angle of each side, because we know all polygons fit inside a circle. So from the corners P and Q, I take 2 lines out 45 degrees, and all lengths are the same, so all sides are the same, so the length of PQ there, swing it out there, and out there. We have 2 vertical sides then, same length again, there and there, and then go in 45 degrees there and there, and then our last side then as a result is going to be like that. I can draw it in heavy then. And that completes parts A, B, C, D of question 2. So hopefully that video helps anybody who may have been stuck in any of those 4 parts.